Leetcode practice time. So two goals. The first one is to see how to solve this problem, and then we are going to put some code here. And the second one is to see how to behave during a real interview. Suppose this is some problem happening in the real interview. So let's get started. So the first one is the first step in the interview is always to try to fully understand the problem. If there is anything unclear, please bring up the question to the interviewer, and at the same time think about the edge cases. So let's take a look. So copy list with random pointer. A linked list is given such that each node contains an additional random pointer which could point to any node in the list or none. Alright, so it has two things, the next pointer and the random pointer. Okay, so return a deep copy of the list. The linked list is represented in the input or output as a list of n nodes. So each node is represented as a pair of okay, so each node is represented as a pair of value random index, where value is an integer representing node.value. A random index is the index of the node where random pointer points to, or none if it doesn't point to any node. Alright, so let's see. Example, something like this. Okay, so I think I kind of understand. I pretty much understand what is happening here. So let's see, node value is between negative 10,000 to 10,000. And node.random is none or pointing to a node in the linked list. So the number of nodes will not exceed 1,000. Okay, sounds fair. So let's see how to solve this problem. So how to solve this problem? One thing I can think about is, we will have two paths. So the first pass is to we are going to go through the linked list and do a copy of each of them and get the linked list instead of setting the random. And at the same time, we are going to have a hash map from the original node to the copied node. And then for the second pass, we are going to set the random index based on the hash map. So that's my thinking. So this one, the runtime is going to be all of n. So space wise, it's also going to be all of n as well. So n is the number of the nodes within the linked list. That's this solution. So let's see. I think it's the best regarding the runtime, but let's see if we can save some space. So I would say, at least we need to find the relationship between the original node and the copied node. So I would say if the list is modifiable, one solution to save the space is we could tweak the original linked list. So for example, we have this linked list and we have the copy linked list. We just set the copied linked list to the next node. So like we insert a node here, like which is the copy node of 7, and similarly we do a copy node at 13, like sometime like this. So this is the first step, and then the second step is we try to set the random node for the new created nodes. So because node.random pointing to, so for example for this one, the node 7, for node 7 the random pointing to 1. So for sure that the next node, the random pointer is going to be the next node of this node. So in this case we set the random node there. This is the second pass, and the third pass we are going to detach the new nodes from the original linked list and form a shiny new linked list there. So for this one, it's gonna need a one regarding the space. Yeah, so but it really depends. You need to ask your interior if the linked list is the input is modifiable or not. So let's assume it's not modifiable because that's easier to implement. And let's do some coding work. So the correctness of the code and the readability of the code, and also the speed of the code. So you can discuss with your interviewer whether it's modifiable or not. So I would say there are two paths. If the interviewer wants to give you some more difficulty, of course he's going to say, okay, this is modifiable, and go ahead to implement the space saving solution. But let's just go with the hash map solution. So for this one, you have okay, so let's see if it's gonna be empty. So it's so that it doesn't say that the head could be empty. Okay, so I will say that will be the hash case. So if head is equal to a non-pointer, then we just return a non-pointer for it. Otherwise, we will have a hash map from node to node. So this is, I would say, node map as a new hash map. Okay, and so let's say iter node iter is equal to head. Well, iter is not equal to none. We are going to say, all right, so so node so node copy is equal to new node iter dot value, and we set is equal to, so we first initialize it, but we need to set the next node. So what if we don't set the next node here, but instead we set the node map in the next pass? So I would say node map dot put this is the iter and the copy, and next time iter is equal to head again, and well iter is now equal to none. We are going to say, okay, node map dot node copy is equal to node map dot get iter. All right, this should be iter is equal to iter dot next, and then we are going to say, okay, copy dot next is equal to node map. So node map dot get iter dot next, copy dot random is equal to node map dot get iter dot random. Okay, so that finishes pretty much everything about the copy. So at last we are going to return node map dot get head. This one, it should have iter is equal to iter dot next. Okay, so copy random list node, if head is equal to none, then return none. So the next step after you're done with coding, the next step is about testing. So testing, you go through a simple test case to explain how this piece is going to work, and at the same time do some sanity checking the logic. And if everything goes well, then you can mention that you want to set up some other test cases to make sure it has good enough test coverage. So let's take a look at this one. We have, so first of all, we initialize a node map, and we do the one pass through the list, and every time we copy the node. So first of all, we copy 7, put the original node and the copy node into the map, and iter is equal to the next one, which is 13. Similarly, we are going to copy 13, and at the next time we are doing another pass, and well, it is not none, we get a copy of the current node. We say okay, next node points to 1, and based on the hash map we have the new copy of the 1, and we set the copy of 7, next pointer of the copy 7 to pointing to the copy 1. Similarly, we set the random pointer. Alright, so I think it looks good to me. Let's give it a shot. Okay, it looks good. Alright, so everything looks good. Like I said, there is another solution, one solution, but you need to do a separate pass, like the third pass on the linked list. But I'm just leaving it for you to implement. So thanks for your time watching it. If you find this video a bit helpful, please subscribe to this channel. I'll see you next time. Thanks for watching.